All right. Let's knock out this last little chunk. So the last thing that they are working on is using Avogadro's number to find atoms. They learned that 1 mole is equal to Avogadro's number of atoms, and the average atomic mass in grams is equal to 1 mole. Now this is early days, so they have not learned the whole Moletown roadmap yet. They've just learned this one little piece to start off with. So let's look at this. It says a certain element has 3 isotopes. The masses of each isotope and its relative abundance is shown in the table below. So we have the mass of the isotope and its abundance. Remember, we want to convert these to decimal form. So 0.80, 0.17, and be careful with this one. We got to go 2 decimal places. So 0.03. Okay. So we're going to calculate the average atomic mass of the element by doing 127.0. That's the mass, times the percent abundance in decimal form, plus the 126.0 times its 0.17, plus the 128.0 times its 0.03. So we can enter that into the calculator in one line. So we can do 127 times 0.8 plus 126 times 0.17 plus 128 times 0.03. And that gets us 126.86 AMU. Now, let's stop and make sure that makes sense. We have 3 isotopes. The highest abundance is at 127. So our average should be closest to the number 127. Well, 126.8 is very nice and close to our 127 value. The 126 was a higher percentage than the 128. So we would definitely see it leaning more towards the 126 than towards the 128. So this number makes perfect sense. So then it says, based on the average atomic mass, what element is this off the periodic table? So we're looking for something that's about 126.86 AMU. So if we look, 127 is too high. 121.7 is too low, but here we have 126.9. That's really, really close to our value that we have here. In fact, if we were to round this to 1 less decimal place, we'd be right at 126.9. So that element was iodine. Capital I. Then it says, if I have a sample of 5.7 grams of this element, calculate how many moles this would be. So we're just going to do the give and goes top left with units, so grams of I. And we know that there's 126.86 grams of I for every 1 mole of I. So we're going to do 5.7 divided by 126.86. That gets us 0.045 moles of I. And yes, I have talked to them about significant figures, so make sure that you have them round to that 2 decimal places. Then it says, using your answer from part C, determine how many atoms of this element you have. So starting with our 0.45 moles of I, we know that for every 1 mole of I, we have Avogadro's number, which is 6.02 times 10 to the 23rd atoms of I. So we're going to do 0.045 times 6.02 second comma 23. Now remember, they will have just learned how to do that second comma thing, so you might need to show them how to do that on their calculator. So we have 2.7 times 10 to the 22nd atoms of I. All right, and that's it, folks.